In the last section, we spoke about the difference between storage and memory in the context of where our contract stores some data. We're now going to look at the other side of the coin, which is the term storage and memory as it applies to how our Solidity variables reference values. All right, so you'll recall that we were back over inside of our create request function over here. Now, figuring out what storage and memory are with relation to Solidity and all this stuff with this code snippet right here is a little bit challenging to understand. So rather than trying to explain what's going on with this code snippet right here, I put together a nice little tiny contract that's very easy to understand and will much more clearly illustrate the differences between memory and storage. So let's take a look at this contract. It's called numbers. It has a single variable, which is an array of integers called numbers. And inside the constructor function, we take that numbers array and push in the values 20 and 32. So if we were to now print out everything inside of numbers, I would expect to see something like 20 and 32, right? Yeah, that makes sense. All right, now here's where things get interesting. Right underneath those two lines, I'm going to add a new line in. And I'm going to write out a line of code that looks very similar to the one that we had just written over here inside of our contract. So I'm going to declare a new variable inside of a function and assign it a value. All right, so over here, I'm going to say that I'm going to declare a new array of integers. I'm going to call it my array, and I'm going to assign it the value numbers, like so. Now when I do that, I still have a warning over here. So if you look at the warning, the first one, it says variable is declared as a storage pointer. Well, that's definitely the same warning that we just saw over in our code. So it looks like there must be something very similar to what we did right here and what we did over inside of our contract. So I'm going to add in one additional statement or one additional keyword to this line right here that's going to make that warning go away. And then we'll talk about exactly what that keyword is doing for us. So right before my array, I'm going to add the keyword storage, like so. Now you'll notice that I still have a warning over here, but I only have one warning now, and it says unused local variable. That warning just means to say, hey, you declared a variable, but you never actually used it, which is totally fine. We don't care about that right now. Clearly, though, it resolved the earlier warning message that we saw, and the same one that we saw over inside of our contract as well. So what's going on with the storage keyword? What's its purpose? Let's take a look at a diagram that's going to help us understand that. Before I show you the diagram, though, I want you to remind you what we spoke about in the last video, which was to say that any of our contract level variables, like the one we have right here, is always stored inside of the storage area of our contract. Just a quick reminder on that. Okay, so now over to our diagram, right here. So here's our line of code, and I've broken it down piece by piece. At the very right-hand side of the equal sign, we have our numbers variable. And as we now very well know, that refers to an array of integers that is stored inside of the storage area of our contract. All right, so now here's the interesting part. When we use the storage keyword right here, it changes the way in which the new variable that we are creating right here, the variable called myArray, works. So this keyword changes how this variable works. When we use the keyword storage, it makes this variable point directly at the exact same location that the numbers variable is pointing at. So because we're using storage right here, the myArray variable will point to the exact same array. Now before I show you anything else, we're going to go back over to the Remix editor. I'm going to show you complete proof that that is the case. Okay? So I'm going to go back over to Remix, and right underneath this line of code, I'm now going to reference my array. I'm going to access the first element, and I'm going to set its value to be 1, like so. So let's now deploy this contract, and we'll retrieve the first element out of the numbers array. So I'm going to click create over here. I'm going to scroll down. Here's our accessor for the numbers array. Notice that this is numbers. That's this variable right here. It's not my array. We have no touch of my array right now. But if we access the first value inside of here, we get back 1. If we access the second value, we get 32. And if we try to get the third element inside of there, we get nothing. because there are only 2 elements inside of numbers. So at this point, after running that constructor, now this numbers array would look like 1 and 32, whereas before it was 20 and 32. So again, as soon as we use that storage keyword, it changes how this variable behaves. It makes this variable point at the exact same location, the exact same data structure. Now at this point, you might be curious, well, why have we never really used storage before? And what would we use besides storage? Okay, yeah, that makes sense. That's where things start to get really interesting. So let's look at an example of what we might use instead of storage. So as you might guess, rather than storage, the other keyword that we can use right here is memory. If we use memory, it changes the way in which this variable behaves. In particular, if we use memory, some additional step is going to come into play. So if we executed this line of code right here with the keyword memory, we would take the numbers array, so this thing that's sitting inside of storage right here, we would make a copy of it, and let's just go through the whole process. Solidity would make a copy of it and place it into memory inside of our contract. And remember, memory gets dumped anytime a function exits. And then my array would no longer point at the array inside of storage. Instead, as you might guess, it's going to point to this new copy sitting over in memory. So the net result of that, well, let's run some code and see what happens. So over here, I'm going to change storage to memory. And then I'm going to redeploy the contract. So we're going to use this new code now. So I'm going to create, and now I'm going to look at the first element inside the numbers array. You'll recall that when we use storage right here, the value of the first element was 1. However, now that this is using the memory keyword, when I click on numbers, it's 20, which was what it originally was. So clearly, in this case, when we modify my array, we are modifying a totally different array. Not the same array, totally different. Okay, so at this point, hopefully, maybe you don't understand why we care about the difference, and I don't blame you if you don't, but you might at least have some idea of how sometimes when we use the term storage and memory, it's talking about where we store our contract data. And then sometimes when you see the term storage and memory, it's talking about the variable declaration keywords storage and memory. And those are talking about how our variables store or reference values. Okay, so hopefully this part is clear right here. Sometimes when we use these terms, they mean one thing, other times they mean another thing. Hopefully that much is clear. But we still haven't really answered the question of why we care about memory or storage at all. Why do we really care? Well, let me show you a very good example of why we might care about these storage and memory keywords. I'm going to delete these lines of code right here, and I'm going to add a new function to our contract, okay? And I'm going to call this new function, let's call it change array, just keep it simple. I'm going to make it public. Actually, let's make it private, just to be very clear and say no one else, like we cannot directly call change array. Only other functions inside the contract can call this function right here. We're going to say that this array takes one argument. It's going to be an array of integers, and we're going to call that array my array, like so. Then inside of here, I'm going to say that I'm going to take the first element inside of my array, and I'm going to set it to equal to 1, just like we were doing it before. Now at this point, we are not calling change array in any way, shape, or form, right? If we create a new instance of this contract, this function will not be invoked. So let's change that. Let's add a call to change array inside of our constructor. So after we add these two values to numbers, I'm going to call change array, and I'm going to pass in the array numbers, like so. All right, so now here's where things start to get interesting. I want you to imagine in your head right now, what would happen if we deployed this contract and then accessed the first element inside of numbers? I mean, look at this. We're calling change array. We pass in the numbers array. And then inside that function, we update the value of the first element. So I want you to just take a wild guess at what it might be. All right, hopefully you've got some idea. I'm going to now deploy the contract. So here's the new version down here. and I'm going to retrieve the first element. So I think that you could agree with me that this first element is going to be either 1 or 20. It's definitely going to be one or the other. Okay, so I'm going to say run that thing, and sure enough, it is 20. So what does that mean? Well, it means that we passed in the numbers array, we received it inside of this function, we then modified that array, but that modification did not change the numbers array. What that means is that whenever we pass a value into a function like this, we are actually making a copy of that array. So change array, we're passing in numbers right here. When that array arrives as an argument inside of our function right here, it has been copied. So my array is a total copy of numbers. And so we're kind of like in the situation back over here, where we have one copy of our array in storage, that's the numbers array, and we have one copy inside of memory. That's the my array array. Whenever you take in function arguments, they are automatically assumed to be memory type variables. So it's assumed that you want to make a copy. It's assumed that you want this behavior right here. So if I wanted to, I could add in the memory keyword right here, and that would just make it very clear to everyone in the world that, yep, in fact, this is a memory variable. It is a copy. It's referencing an array that is stored in memory. However, if we wanted to change this behavior right here, if we wanted to make this behave differently, we could replace the memory keyword with storage instead. When we use the storage keyword in an argument list right here, it means do not attempt to make a copy of the array. Instead, take this numbers array and make exactly this array right here available inside the function. And so this takes us back to this earlier situation over here where we had storage, and that was referencing the exact same array. So let's now deploy this contract and see what happens. So I'm going to click create. I'm going to fetch the first element out of here, and you'll notice that the value is now 1 because my array is the exact same array as numbers. Same thing. So when we modify the first element, we are changing the first element of numbers. All right, so hopefully that makes it a little bit clear why we kind of care about these memory and storage keywords. It changes how we are passing around references to these data structures. Now, if you've never worked with a data structure, or excuse me, with a computer language that works with by value passing versus by reference passing before, some of this stuff might seem just like over the top, way more complicated than it needs to be. However, as you start working on your own contracts, sometimes you're going to end up writing functions where you want to pass in some data structure like an array or mapping or a struct. And in the function, you want to modify that data structure. So you want to change it, and you want to make sure that that new updated data structure is used from the original function that you had called it from. And so that would be a very good example of where you might want to use the storage keyword. Otherwise, if you're calling a function with a data structure and you don't intend to map it in any way whatsoever, then you don't need to add that keyword on. And you can just let Solidity behave as the way that it normally would and not have to sweat it at all. Whew. All right, so that's my spiel on memory versus storage. Again, at the end of the day, the big thing to keep in mind here is that sometimes we're talking about where data is stored, and sometimes we're talking about these how we are referencing these values with our variables. Two completely different subjects. Yes, they're very tightly coupled, but they are different. So when you start looking at documentation around this stuff, it's kind of challenging to understand because you just see these two terms right here thrown around willy-nilly. Now, you're probably wondering back here at create request, well, what keyword are we going to put on? What are we going to do here? How are we going to solve these error messages? We definitely have to put in either storage or memory inside of our variable declaration right here. However, in this case, it's a little bit more clear cut whether we want to have storage or memory. Here's why. Right here, we are creating a brand new request object. When we create a local variable like this, it automatically gets created in memory. Because remember, these are our storage variables. We don't have any other storage variables. So these are the only possible storage variables we can have. Do you see something inside of here that says, oh, I'm going to hold a single request, like only one request at a given time? Well, no, we don't have a variable for that. yeah, we've got this thing that can hold many requests, but we don't have a variable that holds one single one. So this chunk right here creates a new request in memory. Because that request has been created in memory, this new request variable right here, it can't point to a version of this thing in storage. It can't. It doesn't exist in storage. All new request can do is attempt to refer to this new variable, or this new value that exists inside of memory. So we have to use the keyword here, memory, like so. And when we add that in, you'll notice the error messages go away. Now, if you want some better proof of what we have to do here, if you try adding in storage, you'll see that we still have a warning or an error message here entirely. And it says type struct campaign.request memory is not convertible. So it's saying this thing right here is a memory value and it cannot be turned into a storage type value. So that's what that particular error message means. So yeah, we definitely need memory here. Whew, all right, we're done. That's it. That's all I have to say on storage and memory. I know this stuff probably seems ridiculous, very complicated. Honestly, at the end of the day, you probably aren't going to run into this problem too often, but if you do, at least you now have some idea of what it's all talking about. So let's take a break right here, and we're going to continue with our contract in the next section.